Hello guys, I hope you all are doing good. We are discussing the digital circuits, and today in this video we are going to see how we can convert a number from the decimal representation to any other base. We have talked about the decimal number system, binary number system, octal number system and hexadecimal number system, right? So we have talked about these four types of number system, and now from decimal we can convert to the binary, we can convert to the octal and to the hexadecimal. So we are going to talk about all three types of conversion in this video. So in the previous video I already talked about the algorithm. I hope you all have watched the previous video and then you are coming to watch this video because this is a practice session that we have, right? So first we have the decimal to the binary conversion. Now we have any number which is represented in the decimal number system. So 52.125 is represented in the decimal number system, right? So now we will be taking it as the integer part and the fractional part separately. Both of the part are processed separately, and then we will be finding out the binary output, right? So first we will be taking the integer part, right? So take the integer part, and what I said, so if you have to process the integer part to a given base b, you have to divide it by the base b. So 52 is taken and we are going to divide it by base b. The base b is 2, right? So I will be taking 52, I am going to divide it by 2. So when 52 is divided by 2, here I am going to put all of the remainder. Remainder will be 0, right? It is an even number, we can see that, and we will be having quotient is equal to 26, right? So this would be my quotient. Again I am going to divide it by 2 because the quotient is not 0. Again I will divide it by 2. Here I will get the remainder as 0. Again it's an even number, the remainder has to be 0, then the quotient would be 13, right? Again I am going to divide it by 2, so the quotient would be 6, the remainder here would be 1, right? So now again I am going to divide it by 2, so here the quotient would be 3, the remainder would be 0, right? Again I am going to divide it by 2, now the quotient would be 1 and the remainder would be 1. Again when I divide it by 2, the quotient would be 0 and the remainder would be 1, right? So here I have to stop because the quotient has come out to be 0 and I have to put in the reverse order, right? So how I can put it? 1 1 0 1 0 0. This is how I can put this number to represent the 52. Now we will talk about the fractional part. I told you we have to take the fractional part, which is 0.125. I have to multiply it with the given base b. So when 0.125 is multiplied with 2, I am going to get 0.25. Now 0.25 is multiplied with the base 2, I am going to get 0.50. Now 0.5 is multiplied with the 2 and I am going to get 1.00. Because now the fractional part is 0, I have to stop and I have to see all of the integer numbers starting from the first integer, right? So how I can represent this number? This number, which was 52.125 in the base 10, can be represented as, first we will see the integer part. Integer part is 1 1. We are starting from the bottom moving towards upward. 1 1 0 1 0 0, right? Then we have to put the decimal and then we will see the fractional part. So fractional part is the integer part. So integer part here is 0, here is 0, here 1. So 0 0 1, and this is how I can convert the given number from the decimal to the binary equivalent. Now coming to the next number is 19.625, right? So first of all I will be taking the integer part, I will be dividing it by 2, I will be having the remainder 1 and here the quotient would be 9. Again I am going to divide it by 2, remainder would be 1 and quotient would be 4. Again I am going to divide it by 2, remainder would be 0 and quotient would be 2. Again I am going to divide it by 2, the remainder would be 0 and the quotient would be 1. Again I am going to divide it by 2, the remainder would be 1 and the quotient would be 0. Now here I have to stop because the quotient has come out to be 0 and I have to move from bottom to the upside, right? So now we will see the fractional part, which is 0.625. I have to multiply it with 2. So when you multiply 0.625 with 2, you are going to get 1.25. When you multiply it Now the fractional part. So fractional part is 0.25 over here, right? So when you multiply the fractional part with 2, you are going to get 0.50. Now again you are taking the fractional part, you are going to multiply it with 2, you are going to get 1.00, right? So this is how you will be stopping, right? So here till here you have to move, and after that you don't need to move, right? So now how I can represent this number? This number, the number was 19.625 in the decimal representation. 19.625 in the decimal can be represented as the integer. Integer is 10011 point. Now the integer part is 101, right? So this is how I can convert it into the binary form, right? So I hope now decimal to binary conversion is clear. Now we are moving to the decimal to the octal conversion. Again we have the decimal representation, we have to convert to the octal representation. We are going to divide it. So first of all I will be taking the integer part. We are going to divide it by 8. So when you divide the 29 by 8, the quotient would be 3 and the remainder would be 5, right? So now again you are going to divide the 3 by 8, the quotient would be 0, the remainder would be 3. You have to move from bottom to the upside, and then you have to see the fractional part, you have to multiply it with 8, and when you multiply 0.625 with 8, you are going to get 5.000, right? So now this is how you can stop, because the fractional part here is 0. You can directly put the number. The number was 29.625 in the decimal. It can be represented as 35.5 in the octal number system, right? So this was very simple. Again we have one more example for the decimal to the octal conversion. So first of all I have the integer part, which is 444. We have to divide it by 8, and we will be getting the quotient as 55, and the remainder would be coming out to be 4, right? Again I am going to divide it by 8. So when I divide 55 by 8, so it will be coming out to be 6 as the quotient. So 8 6 are 48, and now when you subtract 48 from 55, you are going to get 7. So again you are going to divide it by 8, and you are going to get the remainder as 6 and the quotient as 0, and you have to move from bottom to upside, right? Now let's see the fractional part. 0.456, first it is multiplied with 8, and you are going to get 3.648, right? So here this is the integer, this is the fractional part. I am going to take the fractional part, which is 0.648. again I am going to multiply it with 8. So now what would be the result? You can pull out your calculator and you can find out the result. So it is 5.184. So now here again this is my integer. I have to skip the integer, I have to take the decimal part. So the fractional part is 0.184. again I am going to multiply it with 8. So now what will come? It will come out to be equal to 1.472, right? So now I have to see the integers and I have to move from top to the bottom, right? So now how I can represent 444.456? 444.456 in the decimal can be represented as 674.351 and so on in the octal number system. So you can find out the more fractional representation after the one. You can have the further multiplication of the fractional part and you can get the further fractional digits as well, right? So now coming to the decimal to hexadecimal conversion. Now how I have to convert from decimal to hexadecimal? Again, for the integer I will be using the division method. For the fractional part I will be using the multiplication method. So 25 is first divided by 16. I have the quotient 1 and the remainder 9. Again I will be dividing 1 by 16. I will be getting remainder 1 and the quotient 0. I have to move from bottom to upside. Now talking about the fractional part, we have 0.625 which is multiplied with 16 and you are going to get 10. But 10 in the hexadecimal number is represented as A. So whatever number you are getting, if here also you were getting 11, so you would have represented B instead of 9, right? So if the number was 27, so here I would be having remainder as 11, so that you can represent it as 1B instead of 19. So here, because we have 25.625 in the decimal, it can be represented as 19.A in the hexadecimal, right? So this was simple. Now coming to the next conversion, here we have 115. We don't have any fractional part, so I will be just using the division method. So when you divide 115 by 16, you are going to get the quotient as 7 and the remainder as 3. So now again you are going to divide it by 16, remainder is 7, quotient is 0. So now you have to move from bottom to upside, and you can represent 115 from the decimal as 73 in the hexadecimal. So I hope you understood all of the types of conversion from decimal to binary, decimal to octal, and decimal to hexadecimal. If you have any doubt in any of the question, you can put the doubt in the comment and I will be trying to resolve your doubt as soon as possible. I hope you like this session. If you like it, please push the like button, subscribe to the channel, share it with your friends, and also give me your feedback. Thank you so much.